Hello and good day. My name is Aeron Libanan and we'll be talking about injection molding. So what is injection molding? It's a manufacturing process for producing parts in large volume. So typically used in mass production processes where the same part is being created thousands or even millions. So as shown in the figure, these are the injection molding process components. So which is the cylinder for screw ram, feeder hopper, heaters, barrel, reciprocating screw, the nozzle, motor and gear for screw rotation, non-return valve. So this serve as your injection unit. And for the clamping unit is the mold, stationary plate, movable plate, tie rods, clamping cylinder, and hydraulic cylinder. Next one is why use injection molding. So the principal advantage of injection molding is the ability to scale production in a group. Once the initial costs have been paid, the price per unit during injection molded manufacturing is extremely low. The price also tends to drop drastically as more parts are produced. So here are the advantages of the injection molding. Injection molding produces low scrap rates, and injection molding is very repeatable. So waste plastic from injection molding manufacturing typically comes consistently from four areas, which is in this figure. Okay. Next one is what is the downside to injection molding? Upfront costs tend to be very high due to design, testing, and tooling requirements. If you are going to produce parts in high volumes, you want to make sure you get the design right the first time. So here are the advantages of the injection molding. One is high tooling cost and large required lead times. So here let's talk about the basic injection molding process. Step 1 is the mold closes. The injection molding cycle timer begins when the mold closes. Step 2 is injection. The heated plastic is injected into the mold. As the melt enters the mold, the displaced air escapes through the vents in the injection pins and along the parting line. Runner, gate, and vent design are important to ensure the mold is properly filled. Step 3 is cooling. Once the mold is filled, the part is allowed to cool for the exact amount of time needed to harden the material. Cooling time is dependent on the type of resin used and the thickness of the part. Each mold is designed within the internal cooling or heating lines where water is cycled through the mold to maintain a constant temperature. Step 4 is plasticizing the resin. While the part cools, the barrel screw retracts and draws new plastic resin into the barrel from the material hopper. The heater bands maintain the needed barrel temperature for the type of resin being used. Step 5 is ejection. The mold opens and the ejector rod moves the ejector pins forward. So the part falls and is captured in a bin located below the mold. Step 6 is removing the runner and packaging. Since the ejection molding machine cycle ends on step 5, the process continues. So that will be my presentation about the injection molding. Thank you for listening.